Okay? Let's look at the other factor that can also change what? The power of the test. Say this time we don't change alpha, the level of significance. We keep alpha what? Equal 5%. But what change? We increase what? The sample size from 100 to 400. Okay? So what will change what? The power. Let's see. Okay, let me try one more time. We fix what? Level of significance as 5% unchanged. But we change the sample size. We make what? Sample size from 100 to 400. How this one affect the power of the test? Okay? Now, look at here. A level alpha 5% test. Okay? We know when sample size is big enough, X bar follow what? Huh? Approximately normal. Approximately normal. If it's bigger than C1, too many heads, we don't think this is a fair coin. Or if you see what? Smaller than C2, too few heads, we don't think the coin is a fair coin. And the center of the normal curve is EX bar, which is pi, right? And equal to what? 1/2. It's pi because what? XK follow Bernoulli. If XK don't follow Bernoulli, this is mu, population mean, right? But our case, flipping a coin is what? It's a Bernoulli trial, so it's pi, okay? Now, I want to find how big is C1, how small is C2, okay? And how can we do that? Well, just like before, we need to standardize X bar. X bar minus EX bar divided by standard deviation of X bar. EX bar is what? Is pi, because XK follow Bernoulli. And variance X bar, okay, is sigma squared over n, but variance over Bernoulli is a product of two probability. One for success, which is pi, one for failure is 1 minus pi, divided by sample size, which is n. So under H0 is true, we plug in pi to 1/2. 1/2 times 1/2, divided by what? 400. If I simplified it, become 1/2 over 20. So that's 1 over 40, okay? So if X bar subtract 1/2 divided by 1 over 40 will give me what? A z-score here, okay? So this is a corresponding what? Huh? Z, standard normal, okay? Now, let's standardize C1. C1 minus 1/2 divided by 1 over 40. C1 minus 1/2 divided by 1 over 40. And C2 minus 1/2 divided by 1 over 40. But since we still fix alpha equal to 5%, so upper 2.5%, lower 2.5%. If you check standard normal table, it's 1.96 and minus 1.96. We solve for C1 and C2. So C1 is what? Huh? If you solve it, you get C1 is what? 0.549, which is equal to 54.9 divided by 100. That is to say, if you see 55 heads or more, you see too many heads, okay? Now C2 is 0.451, that's 45.1 divided by 100. That means if you see 45 or less, it's too few heads. You don't believe what? It's a fail point, okay? So, a level alpha equal to 5% test, reject H0 is what? We're gonna reject H0 if X bar is greater equal to 0.549 or X bar is less equal to 451. This one is means what? Too many heads. This means what? Too few heads. Okay. Now, let's calculate the power of the test. Now, power when pi equal to 0.4 is 1 minus beta. Okay. What's beta? Under H0 is force. When this is not a fail coin, the actually pi is not 0.5, it's 0.4. And we fail to reject H0. Why we fail to reject H0? Because data is close to what? To 50%. Is that clear? So it's between 0.451 to 0.498, X bar between this range. And we standardize again, convert this one to z-score. And upper limits, lower limits. Upper limits is what? Upper limit is 6.08, lower limit is 0. What? Well, it's 2.08. Z-score between 2.08 and 6.08. That gives what? 98 point, well, this one is what? Huh? This one is 1.88%. 1 minus that is 98.12%. Anybody still remember when we use alpha equal to 5% and n equal to 100? What's the power? Power is what? Huh? 51.2%. Remember that? But this one jump up to what? 98.12%. Does that make sense? Of course it makes sense, right? What's power? Under H naught is true, you should reject H naught. If you increase from n equal to 100 to n equal to 400, when you have more information, of course you can predict what? Much better. Is that clear? So it become what? More powerful. Is that clear? That makes sense, okay?